Thank you very much for being here. Thank you all guys for being here. Thanks. We're gonna start with the presentation. It's gonna take like 10 minutes live presentation of an overview what Superfluid is about, and we're gonna walk through a application of creating a streaming application. Then, first of all, we're gonna take some seconds. Please go to the GitHub and download the repo, clone CD into the repo, and do your install. In between, as we are streaming, let's see if the streaming works. Yeah, it works perfect. Okay, let's wait for some seconds until all are ready. Okay, first and foremost, what is Superfluid? Superfluid is a protocol which enables you to program digital native cash flows. And within, I mean that we are streaming money with no capital lookups in a way that is 100% programmable on chain. We in the space, we like to think that in the broader space of Web3 that we are building the Internet of Value. And in this sense, we think that internet is to information what blockchain is to value, and we are helping with the real-time finance. Imagine, and this manifests itself with money streaming. Money streaming are continuous payments that flow every second from one sender to a receiver. Imagine that you are a service provider and you are receiving your salary at the end of the month. And imagine that you have to pay your rent the 25th of every month. How you gonna do that? Are you gonna have a lockup of your rent between the 30th of the previous month and the 25th of the next? Superfluid helps with this kind of scenarios. Every recurring payment that you may think of, you can turn it into a stream and send tokens per second. And as you see, here you have the balance in a wallet that is increasing every time. So fine, but how does this work? Actually, Superfluid is a set of protocols, or a set of contracts deployed on chain. And at a high level, we have three pieces. First is the Superfluid host. The Superfluid host is kind of the brain behind the scenes. They connect the different agreements and the super tokens. Normally, you're not going to interact that much with the Superfluid host, but you will need to pass the Superfluid host address when you initialize your SDKs or your libraries. Then we have the constant flow agreement. The agreements are peer-to-peer financial relationships, are open-ended and perpetual. And the most use of this agreement is the constant flow agreement that we will demo in a couple of minutes. The constant flow agreement facilitates the money streaming with a defined flow rate in wait seconds, and the money flows in real time between sender and receiver. The third part, what you can see how we're going to initialize the library. This is actually Solidity, but it will be very similar in JavaScript with our SDK. Very simple, CFA create flow, CFA update flow, CFA delete flow. Now, what are super tokens? Please comment. Super tokens are the tokens that we're going to stream and actually are normal ERC20 compatible tokens with some additional features that provide advanced features for connecting to the Superfluid protocol. They are plugged into the Superfluid protocol that allow us to have the real-time balances, are usable anywhere in the Web3. We have two different super tokens. Ones, which are native super tokens, like the Ricochet one or the Fraction one, or wrappers from existing ERC20 tokens. If you have USDC or DAI, you can wrap your token to DAIX and USDCX. And when you do that, your token start to have these additional features that allow them to be a stream. The conversion between USDCX and USDC is 1-to-1, and that's all. Then when you go to your balance in our dashboard that we will see later, you will see how the balance in your wallet is streaming. And this is actually when you have a really a wow effect. I hope you perceive them. I hope I can transmit the passion I have for superfluid. Then one of the additional one of the additional features we have, hi, come in. One of the additional features we add on top of the tokens is the real-time balance. When you are used to work with normal ERC20, you know that you have a balance, and this balance is fixed, and it will only change when you do a transaction. In the case of Superfluid, you have two balance. One is the static balance, which reflects what you have with your transactions, and one dynamic balance who take into account a certain net flow that will calculate it every second and will be add or subtract to your balance. Then at the end of the day, real-time balance is what you see in your wallet, and you see your balance increasing or decreasing per second. One of the claims I did at the beginning was that it's 100% programmable. And how is about the programmability of Superfluid? You can start sending streams to one EOA or one smart contract, but we can also react to different events from streams. We have the so-called super apps. Super apps are stream-aware smart contracts in the sense that react to creating a stream, updating a stream, or deleting a stream. It means that you can have a super app that receives a stream from someone, and then you can split the stream in several pieces and send it to other people. Or you can delete the stream. You can do whatever you want with the stream. And at the end of the day, what is happening is that we are starting to observe what you can see here is a depiction of the Polygon network with external addresses, external accounts, and contracts. And what you see here is the stream between these contracts and addresses. And this is real. It means that is happening already in mainnet on Polygon. You can be part of it, building amazing super apps. Then building on Superfluid. Before we start with the demo, I would like to present some of the developer tools that we provide to the developers. We have the developer console, where you can see all of the stream, all of the networks that we are present. You can query different contracts, different tokens, either mainnets or the testnets. We have a Superfluid dashboard, which you can see an overview of your streams, and you can then connect with your MetaMask and then start a stream, update a stream, wrap or unwrap the tokens to super tokens. And we have a SDK core, which is we're gonna see in a couple of minutes, is a SDK that allows you to interact with the Superfluid protocol. It's very easy, as you can see here. First we have to initialize the framework, we create a flow, and we execute the flow. We will see it later live. Then let's build. What we're gonna build? We're gonna build a tradable cash flow. What is a tradable cash flow? Imagine that you have some subscriptions and you want to trade these subscriptions. This actually is a normal finance, traditional finance use case, because there are companies which does financial revenue based. Hey, Jesus. All right. Then the tradable cash flow. We're gonna build a contract, which is an NFT, an RC721, and it will receive a stream. Once you transfer your token from one person to another, the stream will be transferred with the token. It means we will have a super app that receives a stream and is an NFT. And when you transfer or sell the NFT to someone else, then the stream is gonna go with the NFT. I think it's clear, at least it's simple, the concept. Okay, that is what we just saw. Let's gonna see the code. Okay, first we're gonna go to the contracts and we're gonna see the tradable cash flow. This is the main contract. We're gonna see the structure. We're gonna drink some water. Oh, it's not on the screen? Why? Hmm? This is
No, this.
okay. Excellent. Thank you.
You can take the seat here.
Well, this is our main contract, the tradable cash flow. And as you can see, it only have one function and it has a constructor. We inherit the Open Zeppelin RC 721 and we inherit the contract, which is a super app that we will see in a couple of minutes. Then when we initiate the contract, we pass the owner of the contract that will be the one person receiving the stream. Then we pass the name and the symbol of this specific contract token, and we pass the host and the token that we want, the host, which is the superfluid host, and the token that we want to stream. By initializing the contract, we will mint only one of these tokens, and we will pass it to the owner. And then the second function this contract has, this method, is actually we override the before token transfer. And then we will tell our contract that every time this token is transferred, please go to the change receiver function. And the change receiver is part of the redirect all contract that we will see in a minute. Then this is the redirect all contract. Let's wait. Well, let's see the structure at the beginning. We are importing the different parts of the superfluid protocol. Especially, we will interact with the CFA1 library, which is a kind of abstracting away all of the low level pieces of the protocol. Then we have some errors. Here we initialize the library. By the constructor, we pass the different relevant addresses from host and tokens. We pass the receiver, which is the person who should receive this new transfer token and the new transfer stream. We register our app. Actually, what we are telling here is we are telling our superfluid host that every time a stream, an event occurs in this contract related to a stream, then it should launch the callbacks. It should hook into this contract. And here we are telling, we have six different callbacks. And here we are telling that please don't do anything with this before agreement created, updated, or deleted. We only gonna hook our application in the after created, after updated, after terminated. It means that once we transfer our token, we say, then now please change the stream from this user to the user, to another user. Here are some modifiers. Here we can see the callbacks. We have after agreement created, after agreement updated, and after agreement terminated. And for the sake of clarity for the workshop, we only call a method which is the same method in all of these cases. We have the update flow method. We have two other methods. One is the change receiver and the update flow. Remember that the change receiver was the method we call when a token is transferred. It was a hook in the before transfer method. And then we have the update flow. Then let's see what is happening in the update flow. We have here two streams. One is the incoming stream that someone is sending to the contract, and we have the outgoing stream, which is going to the person who is owning the token. Then at the beginning, we calculate the net flow rate of this contract. It means, is this contract receiving and sending? What is the balance? Is outgoing more than incoming or ingoing more than outgoing? And then we calculate we query the outflow rate of the contract to the receiver. In the case that we add both flows, and in the case that is zero, it means that actually the net flow is negative and the outflow is positive. It means that actually we are only having an outstream. And in this case, what we have to do is we have to delete the stream because we don't have any stream incoming. Then we have to preserve the liquidity of the contract, then we stop the stream. In the second case, we have the update of the flow in the case that the incoming flow has changed, or in the case that it doesn't have our first flow, it doesn't have any flow outgoing, then we create. And as you can see, so simple as this is actually creating a flow. We initialize the library before, and here we call the method create flow with context. The context here is because we are in a callback and we have to preserve the context of the call. We send it to the receiver with the accepted token and the inflow rate. That's it. That's all. Now, the function that we have seen that it will be called when we transfer our NFT. Here we only see that here we have some methods to check different things, and here we are doing the same thing. Actually, in the case that there is existing flow and the NFT has been transferred to someone else, we delete the flow to the previous person who was the owner of the NFT, and we create a flow to the new owner. That's it. The contract actually. We can deploy it on testnet. Maybe it's gonna take some time. I just deployed one. What do you think? What do you prefer to see? How can we see this in the dashboard, or what you would prefer to see in action? Okay, then we're gonna go. This is a contract we just well, I did it yesterday. Um, I just did, and you can see here is verified. Is the contract we just saw, and we have different methods. Later we will do a transfer and we will see how the token transfers from one person to another. This is the Superfluid main page, and here you can go to the developers and you can go to the console, and here you can see all of the streams that are happening live in the different networks. If we copy the address of the contract here, you can see that is receiving an income, the contract is receiving a flow, and these are the two transfers that I did yesterday from one address to other. That's why now this one is the one actually is receiving himself is the same address. If we go to the other tool, which is the um, the dashboard, here I will have to connect. I will choose Girly. I will have to connect my wallet. And we will see the same flow, but here I have the option to stop it if I want. I can always stop or start or update the streams from the dashboard. Okay, the Wi-Fi is a little bit slow, but let's see, perfect. Good. Here we can see this is the stream that we are receiving. If we open it, we can see that is from the contract that we have. It should be the same as, or I'm not in the same user, sorry. Where is the console? Here, from the 0222. Okay. No, it's not this one. I'm on Mumbai. Sorry. I will have to change the network. Switch network. Actually, when you see this dashboard, the first time when it's real money, you have really a wow effect. Because I was talking before with Ariel, and it's the same. Is if I send you $10, you see the $10 how it's in your balance. But imagine you are receiving only $10 in a day, but the effect of seeing how the numbers are changing and increasing, it makes you having this, whoa, I'm richer than actually I am, because this is something moving, something increasing. Okay, then we are on girly, and this should be the one. I'm still on Mumbai. On networks, Gorley, sorry. Now, here, this one is the one. Uh, and exactly, this is the contract that we are having. Exactly, this is the contract and this sending. Now, I'm going to do a transfer from the token directly in Etherscan with the transfer function from one user to another. And we will see that actually it should bring the stream with it. Okay, then I'm gonna copy. Maybe I'm gonna copy directly. I'm gonna use the same as yesterday. Okay, no, it's not this one. One moment, I'm gonna copy the user. This one was the deployer, and this one is the other one. Then we're gonna go to the contract itself. We can here do a transfer. We will have to connect to Web3. Then we will connect with MetaMask. Now I have to change the user because it picks the last one and actually is the one that should receive the token. Okay, then I go to the next one, to the first one. And now if I refresh in the Etherscan, we should be able to do that. Now I connect again, sorry for that, with MetaMask. And now I'm with the correct user. We go to the safe transfer from from the user address, which I have to copy again. And here. Okay. From the user, from the current owner. Ay, 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 ay. Sorry. I copy this one. I come here. I'm perfect. And I will transfer the first token. It will take, it asks me to confirm. I do that. And now we're gonna wait until it happens, but in between, we're gonna go back to the presentation and we're gonna wrap things up. Um, okay, we're gonna go to the where we left. Let's build. Okay. Now we have seen how the Superfluid protocol works in a high level. We have created a stream, we have deployed a smart contract, and we have transferred one NFT attached to a stream. And hopefully we will see when the transaction succeeds that the stream is moving with the NFT. Then if you want to start building with Superfluid, actually the dev relations team in Superfluid are giving a lot of importance and development experience. And they have put a lot of good documentation, good docs with different examples. You can start there and try tinkering, starting with the SDK. You can also go to the Solidity demos repo. The tradable cash flow is one of them, and start playing with them. We have a YouTube channel where we have the hero to zero learning superfluid, and we have also a very technical and in-depth podcast of Devs Do Something. Please check it out. What we have especially in Superfluid is the Superfluid Wave Pool. What it means is Superfluid is sponsoring different hackathons, but also is having a continuous hackathon every month that you are not required to start and finish the project in the month. Whenever you build something which is relevant for Superfluid, it can be an app, it can be a blog explaining something, it can be even a Twitter line, it can be anything. You can submit to the Superfluid Wave Pool and you can earn some of the prizes. Current for November prices, it ends at the 30th of November. The first place is $2,000. The second place is 1,500 and 1,000. Here we have some ideas. I will, if you want, I can send you later the PDF. And what we also have is Optimism Builder Grant. Currently until the end of November, if you want to apply for a grant when you have deployed some application in Optimism with Superfluid, you can have up to $20,000 dollars for your project. These are amazing things. Then get in touch. You have on the left side Sam Flamini. He's the lead of the dev relations team. He put together this presentation and he's doing an amazing job with his team promoting Superfluid. And I'm Donoso underscore ETH. I'm Superfluid ambassador and I'm Gelato builder. If you don't know what Gelato is actually the decentralized backend for Web3. We provide, Gelato provides transactions and the others provide gasless layers and automate scheduling tasks in the future. Sorry for being so fast, but actually we have 1 minute more. And please, what you have here is the Discord QR of Superfluid. If you can go now and say, hello, we are at Earth Gathering in Barcelona. We want to be part of Superfluid. Victoria is the community manager. She will be amazed to receive your inputs. And you can ask to start with the wave pool. You can ask how you can do it to be in a hackathon or whatever. It's a very embracing community. It's a very welcoming community. If you are in our community and you have some questions, probably you will meet me there because I'm still learning a lot and I'm helping others to learn. Then that was all I have to present to you. And now let's check if I did wrong or good. The transaction has succeeded. Sorry, again, we have the same problem with the, then I will, why it's not happening? Okay, the transaction has succeeded. Hi, we are still in Barcelona. Actually, I realized when I was looking at the video that the last 2 minutes they were not recorded. Then we start where we left. Then here that was the transaction. And if we go to the Superfluid console, actually we will see that the newest stream has been created and the old one has been deleted when we did the NFT transfer. That was actually the last thing I said before, and the people that were in the room, like about 20, 15 to 20 people, they applaud and they were very happy. Believe me, you cannot listen to the applause, but they did. Thank you very much. I will cut the video and put it together with the live streaming. Thank you very much, and see you soon.